Hello and welcome back to the Blade of Akai channel. You are watching Shenzhen IO, and in the last episode we did the remote kill switch and control router. What's this? What's this custom specifications thing? Create and upload a custom specification to Steam Workshop. Ever wonder, this is from Carl, ever wonder where the specs you test against come from? Well, we use a little program called Concept Spec to generate them. I figure you're ready to create your own specs if you want, so I put a link on your desktop. Concept Spec isn't exactly the most elegant program, but it'll do nicely, since you know there's no choice. G says, just remember that good specifications result in good designs, poor specifications result in poor designs. I've seen plenty of good specifications resulting in poor designs. So yeah, there's this new thing to have a look at. This is I think coming off the back of a recent update, so let's have a look at this. So you've got Steam Workshop, right? So yeah, you could come in here, new spec, and then edit, I guess. Opening concept CAD. Open design. Keypad pulse. Okay. It popped up a Lua script, so you'd have to start mucking about with Lua in order to actually do it, and you won't have seen that on the screen. But I'm not going to get into that here because it's not part of the main experience. So let's move on to Pocket I Ching Oracle. Right, so this one's from David, so this is going to get a bit spotty. Have you noticed the I Ching, sometimes known as in the West as the Book of Changes, experiencing a resurgence in popularity lately? No, not a clue. For the benefit of those out of the loop, let me briefly explain. A hexagram is a set of 6 lines, where each line is either solid or broken, with a total of 64 possible combinations. There is obviously much more to it, but I don't want to go into it too deeply. I've been studying the system for a while now, but I wish there was a quicker way to generate the hexagrams. I thought perhaps this ancient divination method be brought... Let's read this again. I thought perhaps this ancient divination method could be brought into the modern era somehow as a pocket device. I think they were missing a word there. Carl Teskey says, 6 coin flips is it then? And then David says, not at all. There is a much more detailed process through which one arrives at the reading involving yarrow stalks. I stopped by to try to describe it to you, but you weren't at your desk. Suffice it to say that we will need to generate the readings in the proper way if it is to be taken seriously as a divination tool. G says, I found a part that works for this. It implements the physical yarrow stalk method in a miniature MEMS. Strange. So we can just create the display for the result. Obviously, interpretation is up to the user. So we're just, this seems like a silly thing to do. So apparently we're taking some hocus pocus reading type thing and turning it into a device. Let's rename this thing. So pick D1. Okay, right. What's this? Oracle Master? Is that a new screen? And this is the this is the yarrow stalk generator. I've not seen this, but I can't do anything with it anyway. Right, button and Oracle are simple inputs connected to a MEMS based Oracle engine. Where's button and Oracle? this Oracle and that button? I guess. Display is a display output corresponding to a custom LCD screen designed to visualize I Ching hexagrams. When the button is pushed, the Oracle engine will generate 6 values corresponding to the 6 lines of an I Ching or I Ching hexagram from top to bottom. Okay. From top to bottom. 6 lines. 1, 2, 3, 4, 5, 6. There's 2 columns. Oh, I guess, are these like you turn them off and on? Alright, there's 1, 2, 3, 4, 5, 6 pins on there. I don't know what they're for. Ah, is that for each line, is it? When the final value is generated, the display should be updated to match. So verification, yeah, look, there you go. Oh, I see it, it bridges the middle bit. So, right, let me try and interpret this. So we get a button press, at which point we need to start reading, I guess. And when we do, we're looking for, so that was 100 for 2. How is it? Hang on a minute, it said from bottom to top. Okay, so that is right. So this timestamp 1, 2, 3, 4, 5, 6 is the signature, right? So we've got basically six pulses back to back. So the first 2 are these 2. Then there's a gap, which means that's off. Then there's this one, which is on. And then there's that, which is off. And then this one that's on. Okay. How are we going to do this then? So, is this a... I'm guessing that's a pin, right? And I can SL... if I do this, test equal P0 and then I'm gonna have a no, is it that? No, it's that, isn't it? Sleep. We're just gonna sleep for 1, I guess. And then I'm going to say test whether P0 is equal to 0. If it is, we're going to jump out to the sleep. Jump out to the sleep. So on and so forth. Otherwise, we're gonna move, I don't know, 1 to x1 maybe, and then we're gonna do, I think we're gonna need one of these guys, and then we'll just bridge the 1s. Now hang on a minute. Hang on a minute. Yes. Okay. Okay. Let's move that there. Let's move that there. Like that. And then can I... Is that connected? I don't think it is it? So let's move that there. No. Like that. Let's move that there. That should now be connected to there, which I can then bring out to... Oh. Okay. Yeah, I'm thinking about this. It's going to get more complicated. I need this board to do a little bit more than what I initially intended it to do. So let's do all of this. Right. That's got no. That's got to go there. This is going to come up and go there, like so. And then I'm going to move. This is going to have to be a loop. And then we're going to have to move 1, 2, 3, 4, 5, 6. So if we move 6 to AC, and then in the loop we move, we have to do a test equal no, we need an initializer first, so let's move, say let's move -1 to x1, then we'll move 6 to, why is that? Oh, because I haven't got it connected. Okay, well, that's fair enough. I'm going to need to put this somewhere like there. Maybe bridge that way. And then I'm going to need one of them. I'm going to need one of them. Bang, 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 bang. Like this. And then I can... Is this pins? I don't need pins, do I? I just need these things, right? I don't even need to do that. Do that. Do that. We run out of instructions. Sub 1, and then we need to jump back to the loop and do a sleep. Okay, well, that's a template for what we need to do. Let's get rid of that a minute. We're going to need one of these. What are you doing? Get back. Yeah. Now I've got to think about this because I've got to get the order of the numbers right. Because what I want to do is I want the values to come in, and then I want to build the number up so I can just throw it straight at one of these boards, which will then light up the right thing. Right, I think I'm going to have to bite the bullet. I think I need a RAM. RAM? Yeah, that's a RAM. Add 1, test less than 6, jump to sleep if it isn't less than 6, otherwise we're sleep. Jump loop. We've added the 1 already. Okay, I think that kind of does what we need it to do. Let's get rid of this cruft. So P0 is there. Let's get rid of that a minute. Right. So if I put that there, X0 is going to have to come up to the address bit just there, and this is going to have to be X1 like so, then that is going to have to come up into there like such. So what's going to happen is gotta root this down. Oh no. No. Okay, but I can do this instead, right? I can get rid of that, and then I can slap the bridge in there, and I can carry on with this. There we go. Right. So what essentially is going to happen is when we get this pulse in, it's then going to like kick things off. So we're going to move 0 to ACK, and then we're going to move the value of ACK into the address to reset the address and put us back here. And then we're going to loop while we're getting values, and then we're checking each value, and then if it's a high value, we're going to put 1 into x1, which is ultimately going to end up in D0, and that's going to put like a 1 or a 0 there, then it's going to put a 1 or a 0 there, there, and so on for 6 addresses. I guess we're going to need some way to I didn't think about this bit. We're going to need some way to inform the other boards to start doing their thing. Yeah, so if I move 50 to P1 here, I've got that connected over here, and then I can test equal P1 and 50. Otherwise, if it's not, jump to sleep. Actually, this would need to be a gen pulse, and in that scenario, we just want to jump to start. Oh god, this is complicated. Right, let's move all of this out of the way, and the data's coming in. Right, so if x0 can route into there, then x1 can go to there, and then we need a sleep down here of 1. What? Where? Oh, I just need to write sleep again. Right, is that gonna get anywhere? Jump to sleep. It's sleeping. Now it's 50. It's not 50 yet, so we're gonna jump to sleep. TGT P1, move 1 to x2, add 1, 1, 0, 1, 0, 1. Now we gen the pulse to 50, but that's just made it 100 only. Oh no, it doesn't gen a value of 50, it gens 100. Doesn't it? For 50 seconds that will be. Unless... I don't think I've got enough instructions. Keep whacking the microphone here. We could move 0 to x3, then move x2 ACK to x1, 0 to dat. We can do all of this, and then we can move, yeah, we could just do it more simply like this, and we can say move that to x3, that one to x3, and we move this like so. I'm going to route this up this way, and then these guys are going to have to, that's going to have to go in there, that's going to have to go in there, and then we can say move x0 to x2, SLX x0, move x0, I'm going to make that 1 actually, 1, 1, 1, 1 to x3, and then back to the start, because we're only going to get 2 sets of numbers out of this, right? I'm not checking it. I've spent so much time on this already. Let's just try. Right, where are we at? So 11010 11010 move 0 to x3, which instantly does this, sets the pointer back to 0. Then we're looping. And then we're going to say set the first. Why am I reading off x0 there? That should be x1. And that should be x2. Let's try this again. Right, okay, there we sent 0 to the address, so yeah, we're back at the right place. And now we're going to write the first value to dat, to ac, then the second value, then the third value. And then we're understanding whether this is low or high, which we kind of don't. I can improve this. Right, it doesn't matter whether it's low or high in the transmission. It just matters whether we set 1 and then loop. Otherwise we fall out. Right, let's try this again. And then 1 there, then 0 comes in. We've reset the address. Read, test, move the data, should be 11. That now kicks off the top board, which instantly knows the first value is for the second, the lower board. Yeah, and then we jump to the loop, we read, and then we test again. Send the value as 101, which it is, and then we fall through. Yay! Right. Right, what happened there? Typical. Right, so we get to here. Step. Right, the address. Right, are we not setting the address right here? The address is on there, right? Right, at this point, we send the data over here. We jump to start up the top here. If it's less than 100, we jump to sleep, and then we wait until this point where we say we move 0 to ac, we move ac to x1, why hasn't this updated the address? Oh, have we got 2 different pointers, so you can have 2 different things reading off it at the same time? That's interesting if that's how it's working. Okay, I can't see anything written about it, not easily accessible in the documentation about 2 different pointers, but it seems that address 0, data 0, and address 1 and D1 are different pointers, which is kind of a problem. I'm not sure how I'm going to get around that. the only way I could think of would be to bridge these two, but then this is going to say, yeah, part connected to self, which is not what I want. What I could do, I think, is instead of going down this way, I can put the bridge there and use it for the pin, and then make X1 go down the back to A1. Let's try that. Okay, let's delete that, put that in place, get rid of that, and then I've got to put that out there like that. Let's see if that fixes the problem. Yep, we're back. Yeah, that's overwriting the same piece of memory now. That's perfect. That's exactly what I wanted. Right. This looks like it might be working now, so let's just simulate. Okay, we did appallingly, but I got it working. I don't know how these guys figure this stuff out. I really don't. Electronics was never my strong point. Coding, different story, but electronics itself, no, not very good at it. So the lines of code is kind of okay, but my power usage is way high. Not sure where that's happening, and the production cost is obviously high because I'm using so many components. Okay, so I had a little play around because I was not happy with that last solution, how it ended there, and now I've done it a little bit differently, and I would like to hope a little more cost effectively and a little more efficiently on the code as well. So what I'm doing is I'm basically taking the pulses here from the Oracle, and I'm taking them into one of these boards, which is a DX300, which is then converting the 100 pulse into a number 1 on the X bus. And then all I'm doing is I'm using a very simple loop. We set dat to 0 for the first loop and dat to 1 for the second loop, and all we do is we immediately just pull this value from the DX300 and put it straight into the digit on the accumulator, and then we sleep because there's it's a pulse for 1 second or 2 seconds or however many seconds. Then we sleep, and then we read the next value as it comes in via the DX300 and put it into the next digit on the accumulator. Now once we've read the first 3 values, we then we check the situation for the DAT, and regardless of that situation, we immediately then move the value to X2, which I've got rigged up to this little board here. And I'll explain this board in a minute, and then we loop back, and then do the same again for the next 3 values, and then we again send those values to this little board the second time, and then we fall through the loop and then wait around up here until we get another button press. Now, what's the purpose of this board? So this board basically allows us to use just one output on here, which simplifies the logic in here, and then this comes in, and then we can use a sleep, and then we sleep on the X0 value, and when it comes in we have to move that first block of 3 values, which might even be 2 or 1 digit, but it's actually a block of 3, and we move that into the accumulator, and I'll explain why in a minute. And then we sleep again, and then we wait for the next chunk of data to come in, which we then move immediately to X3, and then we flush out the accumulator to X2. Why am I doing it that way? Well, basically, if I take the first block and then write it, and then get to the next block and then write it, what happens is the verification fails because I've written some of the output before I've read all of the input, which is a fail state. So yeah, I had to kind of buffer it in this little board down here, and that board I was using anyway, but I was just immediately going SLX X0, move X0, move X0 to X2, then SLX X0, and then move X0 to X3. And that's where the fail was coming in. So I had to kind of push things into the accumulator and then spit it out all in one go, so it was done in one tick and happened at this point here. Now, I don't know how this stacks up against my other solution on the figures and stats and stuff, but I'm hoping it's a lot better than it was last time round. So let's take a look. Look at that. So I've got I'm with the masses on the production cost and with the masses on the power usage, but check out the lines of code. I'm ahead of the curve there. I like that. I like how I've done that. I'm betting there's some there is some more optimizations that you could do. We haven't even gotten into using this other componentry down the bottom here yet, so maybe there's more to gain. But that's where I'm going to leave that one, and we're going to read the emails. Splendid! How wonderful that such a device was created right here in China, where it all began. I'll probably even use this oracle myself, as Xiaomei and I approach our wedding day. And then G is saying, David is more Chinese than even a Chinese person. And then he said, thanks. Oh dear, he's one of those people. Anyway, I'm not going to do a second puzzle on this video because I'm conscious that the Shenzhen videos I'm doing are getting rather long because it's taking me an awful long time to come up with a solution, and then editing it down it's difficult to decide what to put in, what to take out. So if I just do a puzzle an episode, it's going to make things a little bit easier. I still have to be quite ruthless because there are an awful lot of time just sat there with me looking at the screen with my jaw wide open going, what the actual deuce is going on here? But we did another one. I hope you liked this one. If you did, don't forget to hit like, share and subscribe, and I shall see you all in the next episode of Shenzhen IO. Thanks for watching, and bye bye for now.